So pressure is a prediction of kinetic molecular theory. Kinetic molecular theory predicts pressure. Pressure is the result of collisions between the particles in the gas and the surfaces around them. Pressure allows us to drink from straws, inflate basketballs, and move air in and out of our lungs. That's probably more important than the basketballs, huh? It allows us to breathe. Variation in the Earth's atmospheric pressure creates wind and helps us predict weather. That's why the meteorologists are always talking about high pressure systems and low pressure systems and stuff like that. So pressure is exerted by a gas sample as the particles hit the container. Here we have a lower pressure system and a higher pressure system, and the difference is that there's more particles in here. More particles means more collisions, which means more force. The area of the inside of this container is going to be the same, but this higher pressure is due to the fact that there are more particles in there, and so the force will increase. Pressure imbalance is what causes your ears to pop when you change elevation. We go up to Grant Grove periodically, and you drive up the mountain, and there's a pressure difference that begins to happen between your outer ear and your inner ear. There is air on the inside of your eardrum, and that's connected to the inside of your throat through your eustachian tubes, and the outside of it is open through your ear canal. As the outside pressure goes down, the pressure inside your ear is the same as it was when you were down on the valley floor, and it causes your eardrum to bulge out. Not comfortable. If you have an ear infection, it's really, really not comfortable. So what happens? Well, you yawn, you chew gum, you pop your ears, right? That popping sound is the air pressure coming out of the ears through your eustachian tubes. That's why yawning helps, is because they're in your neck, and then when you get them straightened out, they're more likely to open up. Then the reverse happens when you're coming back down. Your ears finally got adjusted to being up there, and then when you come down, then you have a low pressure inside and a high pressure outside, and your eardrum bulges the other way. It affects your hearing too, because in order to hear well, the drum has to be able to vibrate. And when it's bulging, it doesn't vibrate as well. Pressure is a quantity that can be measured, and so of course we need units for it. The simplest unit is the atmosphere. The abbreviation is ATM. This is just the average pressure at sea level on the Earth. It's the pressure of the atmosphere, so we call it 1 atmosphere. The SI unit for pressure is the Pascal, it's abbreviated PA, and it is defined as 1 Newton per meter squared, or per square meter. That's more of a physics definition. It's more useful for physics. A Pascal is much smaller than the atmosphere. There's 101,000 pascals in 1 atmosphere. Another unit is the millimeter of mercury, which doesn't seem like it should be a pressure unit, because a millimeter is a unit of length, and mercury is a liquid element. So how do we get pressure out of a length of an element? Well, it has to do with the mercury barometer. A mercury barometer is simply a tube of mercury that has been inverted into a dish of mercury. And so this is a little bit like the whole straw thing. When we invert this tube of mercury, the mercury wants to fall down, but the atmosphere is pushing on it to keep it up. And so it comes to a point where it balances. And it does that at 1 atmosphere of pressure when the column of the mercury is 760 millimeters tall, or 29.92 inches. If the atmospheric pressure decreases, then the height of the column of the mercury decreases. If the atmospheric pressure increases, the column of the mercury gets taller. I've watched my kids play in the bathtub, right? And you take a cup of water and you have it under the surface of the bathtub. Oh, let's draw a picture. So here's your cup of water upside down. And then when you raise it up, so it's the mouth of the cup is still under the water stays up in the cup, doesn't it? And it's kind of fascinating because it shouldn't happen, right? Because if you hold a cup of water upside down, the water's supposed to come out. And so kids are doing these little science experiments. They're like, wow, look, the water stays in there. Then you pull it up farther so that it can get out, and it comes out. But why doesn't the water come out when you lift the cup up? Because there's atmospheric pressure pushing down. And it can push down hard enough to support that small column of water. Now, water is less dense than mercury. And we were talking about the straw and how you could make a straw that would work up to about 10.3 meters. If you made a barometer like this using water instead of mercury, the height of the column of water would be 10.3 meters. That wouldn't be real practical, would it? To have a 34-foot tube be your measure for the atmospheric pressure. It works well with mercury because it's 13.6 times denser than water is. So if you wanted to make a straw for mercury, it could only be a maximum of 760 millimeters of mercury tall. But this length, the height of that column of mercury, is a unit of pressure. So here's a table, and you may need to refer to this frequently. It's also inside the back cover of your textbook, and this gives the different pressure units and their relationship. So all of these are equal to each other. That's a little different than how the other tables of conversion factors and stuff are set up. So 101,325 pascals is equal to 1 atmosphere, which equals 760 millimeters of mercury. And that's an exact number. It's defined. 1 atmosphere is defined as exactly 760 millimeters of mercury. That equals 760 torr. This is just a different name for this same size of pressure unit, millimeters of mercury. The guy who invented the mercury barometer was named Torricelli, and so they named a unit after him. It's a torr. So a torr and a millimeter of mercury are exactly the same size. 14.7 psi, 29.92 inches of mercury. There's a mistake in the table in your book. So this red part here, you might want to correct that. Can't remember what it said, but it was wrong. These guys over here are the ones that you should memorize. We're going to use those a lot. It's just one number to memorize, 760. We're going to use those a lot. So we need to be able to convert pressure units, and this is just dimensional analysis. So converting 1.25 atmospheres to torr. These are going to end up being one-step conversions, which is nice. So we're going to multiply by the unit that we want and divide by the unit that we're given. So I'm given atmospheres. I'm going to divide by atmospheres. It asks me to find torr. I'm going to multiply by torr. One step. Because of how the table is set up, these are all equal to each other. So all I have to do is go over to the table and find the one I need. So there's the atmosphere is 1 and torr is 760. So I just write those numbers in front of the units that I set up here, 760 and 1. And then I do math. Calculator. 1.25 times 760. Calculator says 950. Torr. That number 760 is an exact number, so it's not going to limit our sig figs. So what we had over here was 3. We should have 3 there. Technically that's not 3. If I put a decimal point in there. Come on. There we go. I don't know why that was so hard. Or better, 9.50 times 10 to the 2 torr. Bottom one, same idea. Convert 30.15 inches of mercury to millimeters of mercury. So I'm going to write down the number that I'm given with its unit. I'm going to multiply by the unit I want, which is millimeters of mercury. I'm going to divide by the unit that I have, inches of mercury. So the units work out. It's all about the units. So over here, I've got 760 millimeters of mercury and 29.92 inches of mercury. I'm going to write those numbers in front of my units. Millimeters of mercury, 760, and inches is 29.92. So 30.15 times 760 divided by 29.92 equals. I'm going to round this to 4. My starting number had 4, the sig figs. This 760 is exact, meaning I can ignore it in terms of sig figs. And this one has 4. So my answer should have 4. I'm going to take 765.842246 and round it off to 4 significant figures, 765.8 millimeters of mercury. Any questions? Let's do one more. Convert a pressure of 173 inches of mercury into pounds per square inch. (173 inches of mercury). I just want the units to work out. I want to divide by inches of mercury, and I want to multiply by pounds per square inch. I put the units in first because the units tell me what to do before I get all confused with numbers. Then I go to the table of pressure units and I write the numbers that are in front of these units. I get 14.7 psi is equal to 29.92 inches of mercury. 173 times 14.7 divided by 29.92. 84.99666578. How should I round that? To 3, right? Because 173 has 3 sig figs, 14.7 has 3. 29.92 has 4, that's more. So I'm going to keep 3. I look at the next one, that's 5 or greater, so I'm going to round up, which rounds the 9 up to a 10, which runs the 4 up to a 5. And I end up with 85.0 psi is my answer. Any questions?